So this is one example. We are using an array to implement our NQ operation and dequeue operation. Here we have a circular queue with a size n equals to 5. So let's say this is 1, 2, 3, 4, 5. Initially the rear is 0, front equal to 0. Now keep in mind here, because we are assuming that this index starts from 1, 2, 3, 4, 5, so we are keeping rear and front equal to 0. Okay, but when actually you implement with the array, your index start with 0. So you, in place of starting with 1, we will start with 0. So I will also show you that how we are actually going to use an array. But let us first understand we have 5 positions, and we have indexing as 1, 2, 3, 4, 5, and rear equals 0, front equals 0. So if you insert 10, so if you insert 10, then what you will do, you will, whenever you insert, you always look to the rear index. Okay, so you need to check the overflow condition. So how you check the overflow condition? If rear is not equals to the last index, so here this is not overflow, rear is not equals to last index. So what you will do, you will simply increment the rear. So rear will become 1, and front is also become 1, because this is the only element. So whenever you find that your front equals to, means whenever you find your queue is empty, you will insert the element, and both will point to the same index. So here you insert the 10, and front and rear will be pointing here. Again you insert. So every time when you insert, you simply increment the rear. So now front is pointing to 1, but you increment the rear. Now rear is pointing to 2, and you have inserted 50. Now you are inserting 20. So again you will be incrementing the rear. So rear pointing the 3, and you insert the 20. Front will remain at the same position. Okay, this is actually 1, not 0. Front is 1, right? And insert 70. Again you will be incrementing the rear will here, so it will insert 70 here. Front remain at the same position. So rear is 4, front is 1, and then you will be deleting front. So when you will delete it always happening at the front, so this will be deleted, and front will point to 2. So front will be now 2, and rear remain the same. There is no impact on the rear when you do the delete operation. So this is the general behavior, that how the things are working. But now we will see in context of arrays. So we will, in place of using this 1, 2, 3 index, we will use it as a 0 index, because in the actual scenario our array starts with 0. So let us take this as a 0 index. Okay, so what I am going to do is I am going to just change this indexes. This is 0, 1, 2, 3, 4. So I'll just change all these indexes so that it can represent our real array. So here you can see our queue is having a size 5, which goes from index 0 to 4. Now we will have a look of this algorithm. So initially the front and rear equals to -1, front and rear -1. This is queue is empty. Now when you insert, so when you insert what is required, so you need to check all this scenario. If front and rear equals to -1, means this case is actually applicable. We have many cases are there. If this case is applicable, then what is required? You need to set front equal to 0, rear equal to 0. So front equals to 0, rear equal to 0, and you will insert the item into the uh, C of Q. So you will insert this item at the 0 index. So front and rear is pointing to both. This is also pointed to by the rear and front, and you insert the element here. Now next insert 50. Okay, now you will look which condition is holding. Front equals to -1, no. Front equals to 0, yes, but rear is not equals to -1, and also front is not equals to rear plus 1. So this is also not true, this is not true. Rear equals to n-1, this is also not true. N-1 means last index. Then in that case what is required? In that case simply increment the value of rear and insert the item into this index. So what is required? Simply increment the rear. So rear becomes 0 plus 1, that is 1, and in the 1 index you insert the value 50. Again insert 20. Again all these condition will be false. You will go here, increment the rear will point to 2, and in the 2 index insert 20. Okay, done. Then 70, again all the condition will not match. Simply increment the rear, so rear becomes 3. At the 3 index you insert the 70. Then next delete. So when you go to delete operation, we need to look to the delete algorithm. So what actually is required? You simply look to the front and increment the front. So here if you see the front is 0, you increment the front becomes 1, so front is not now pointing to this, and you take this value out. This is how we are working with the insert and delete operation. So we'll further proceed with the same example. Now this is the so if you see here, already we have did 1 2 3 4 5 6 operations. Now the next is 7th operation, and also I will show you that how we are working on these insertion and deletion using this algorithm. So this is a deque algorithm, which is for delete, and this is your NQ algorithm for insertion. So now at this point of time, front is pointing here, rear is pointing here, and we will just look to the algorithm and see how operation can be performed. Now you want to do NQ operation, insert. So what you will do? You will check, is front equals to minus 1? No, this is not applicable. Front equal to 0? Not applicable. Just keep in mind these indexes are 0, 1, 2, 3, 4, because we are working with array, and array starts with 0 index. So I am just keeping all these indexes as per the array. Now, so this is not mat, this is not mat. If rear is the last index, no, rear is not the last index. Now if you see here, rear is actually at the index 3. If you look here, index 3, and last index is 4. So still we are not reaching to the last index. So what is required? You simply increment the rear and insert the value at this index. Insert the item at this index. So you increment the rear becomes 4, and you insert the value at this index. This is required. Now insert 40. Now out of all these given situation, this is not true, this is not true, but rear equals to n minus 1. Rear reach to the last index. Then set rear equals to 0. What you will do? You will set rear equals to 0. So that means after this, rear will be here. And also if you just look, I have made a change in the previous algorithm we discussed. You have to insert the element here. That means CQ is the name of our array that we are using to represent the queue, and the rear is the index. So now we have set our rear index to 0, means at a 0 index you insert this item. So at a 0 index we insert this item 40. Now there is no change in the front will remain the same. So whenever you are doing the NQ operation, we are basically dealing with the rear part. Now insert 140. Now if you see here, which condition is being met here? If you look all these scenarios, if front equals to 0 and rear equals to minus 1, so front is not equal to 0 and rear not minus 1, but we have two conditions here, or front equals to rear plus 1. If front equals to rear plus 1, that means it's a case of overflow. So what is front here? Front is 0, and what is rear here? 0. Front is 1 here and rear is 0. So if you do 0 plus 1, that is equals to 1. So if front is actually rear plus 1, this condition is true, and whenever this condition is true, you will say that it is overflow condition. So you say this queue is overflow and you are not allowed to insert. So 140 is not allowed to be insert. Okay, this is the overflow case. Now the next is delete. So in case of delete, you need to check what is the situation. So we have front is -1, no, front is not -1. Front equals to n minus 1, front is also not n minus 1. Okay, the front is 1 here, right? Front equals to real, this is also not correct. Then what is required? Simply set front equals to front plus 1. So what you will do, you will simply now keep in mind this is 0 1 2 3 4 index. So front was actually pointing to index 1. Okay, here. So now if you look at this, nothing is actually matching. So in that case, simply if all are false, then you go to this part, front equals to front plus 1, and you will pointing to this. So you will see that front point to this, and you just take this item and assign it to the item. Then delete. Again, when you delete, now delete is always possible from the front only, right? So when you say delete operation or deq operation, you have no choice to say that delete the fourth element or the sixth element. You can only say deq operation, that will always delete from the front end. So none of the cases are matching. You simply move to the next, and this is now pointing by the front, and this will be deleted. Delete again you will see that none of the cases matching, and you increment the front, and you will now front will point to this fourth index, and this will be freed. Now these index are free, and if you want to insert any element, then this can be utilized. So at this point of time, you can see that rear will remain the same. Whenever you apply the delete operation, rear is always the same. Only the front is keep on changing. Front becomes 2, front becomes 3, front becomes 4. So we have not only discussed this algorithm, we have also checked this algorithm on one numerical. So I hope you have understood that how to work on these NQ and DQ operations in the circular queue. And this is all for circular queue. Okay, so thank you very much. See you in the next lecture. Bye for now.